Okay. So let's talk about this conversion from polar coordinates to Cartesian coordinates, right? That's X and Y. Ooh, that's a Y. You guys get it. Um, there are formulas for this. Okay. We know that we can come up with X by taking r times the cosine of theta, and y is equal to r times the sine of theta. Feel free to use those formulas, but let's talk about why they work. Okay, I have to move myself up here because negative pi over 6, where is this point? It's at negative pi over 6, which would be down here, and then negative 1 unit away. So if we're negative 1 unit away from negative pi over 6, we extend this to be a diameter, and the point is actually 1 unit. And I'm just going to put it out here just so that I have a big enough picture. Okay, I don't have a scale drawn up. So normally negative pi over 6 would be here, but because the r value is negative, the point's actually pushed into the other or along the diameter to the other side of that angle. So this is where this point exists. We know that this is a pi over 6 angle, okay, which means this is a pi over 6 angle, and pi over 6 is 30 degrees, okay, because what we're going to do is we want to come up with the x coordinate and the y coordinate. The y coordinate is that distance, and the x coordinate is this distance. So the x and the y coordinate form a right angle, right? Or those displacement symbols, y coordinate, x coordinate. They form a right angle, which naturally forms a right triangle. And if we're dealing with right triangles, it might benefit us to use degrees instead of radians. So here's what we know. We know this is a 30-degree angle, and we know that this has a length of 1. Now, I know it was negative 1 from the beginning, but we're not going to use the number negative 1 to talk about a hypotenuse. Hypotenuse values are always absolute values, so this is positive 1. Okay, so here's what we know. Can take two different approaches. We'll take the systematic approach first, and then we'll take the shortcut approach second. Okay, the shortcut approach, if you're super zen with your unit circle, you might already realize where we're headed with that. But so what do we know? We know that this side length corresponds to this angle and this side length with a cosine statement. So we could say that the cosine of 30 degrees is equal to the adjacent side over the hypotenuse, right? So the cosine of this 30-degree angle is x over 1. What's the cosine of 30 degrees? Radical 3 over 2. And x over 1, that's just x. So what we're saying is this distance right here is radical 3 over 2. The picture, however, right, the drawing that we've created for ourselves tells us that this is actually negative radical 3 over 2. Okay, so that's our x coordinate. For the y coordinate, right, we have the opposite side in the hypotenuse. I could make this same statement, but I would say that the sine of 30 degrees is equal to x over 1. And the sine of 30 degrees is 1/2. X over 1 is just x, so I don't really need to do anything to that. Now, what is this? This is a positive value because it would be above the x-axis in the Cartesian coordinate system. So we say that this is positive 1/2. So these are the coordinates of this point. That's the systematic way, using a right triangle, writing trigonometric statements, and then evaluating those trigonometric statements with our knowledge of the unit circle, right? I'm not using a calculator to do this, not because I can't, but because I have the ability to evaluate the cosine of 30 based on coordinates on the unit circle. Speaking of the unit circle, what is the unit circle? The unit circle has a radius of 1. So because this was 1 right off the bat, we really are looking at the unit circle right here. And this 30-degree reference angle means that the angle that we're looking at is 150 degrees or 5 pi over 6. And what are the coordinates on the unit circle for a 150-degree angle or 5 pi over 6? They're these. Now that only works because the radius is 1. So we are literally using the unit circle for that. Okay. If this was 2, would be a different story. I'd have to do these calculations a little differently. Okay. So how are we doing this? Plot the point form a right triangle, use what you know about reference angles and right triangle trig, SOHCAHTOA, and the Pythagorean theorem to come up with these values. And that's another thing. Once I found x, I could have used the Pythagorean theorem to find y, right? I don't know if you would have wanted to do that. You could have said radical 3 over 2 squared negative radical 3 over 2 squared plus y squared equals 1 squared, ... I don't know if you want to do that, but you could do that as well, okay? But we were just using a cosine statement and a sine statement and then solving for the unknown to get these measurements.